Have you ever stopped to think about how we go from like this glowing, red-hot blob of metal
Yeah.
to like a perfectly formed, intricate part?
Yeah, it's pretty amazing.
It's not magic,
No?
even though it seems like it. We're doing a deep dive today into the often overlooked,
Mm-hmm.
but really crucial world of die casting cooling systems.
Right.
The unsung heroes
Yeah.
that make these transformations possible.
Yeah, for sure. It's wild how, just the simple process of
Oh.
cooling can actually make or break a part.
Totally.
Even a few seconds, if you miscalculate the cooling,
Oh, wow.
it can be the difference between a perfect part and just a warped, unusable mess.
Wow. I bet most people have no idea how much precision is involved.
Yeah.
So let's break this down a little bit.
Okay.
We're talking about casting mold cooling systems,
Right.
but what does that actually look like in practice?
So basically, you have this network of channels that are built right into the mold itself.
Right.
And it's kind of like a circulatory system.
Right.
And this carries the cooling medium, and that regulates the temperature of the molten metal as it solidifies. And the placement and the size and shape of these channels are critical to make sure that it cools evenly and you don't get any defects.
So it's like a vascular system.
Yes.
For them. And I remember reading that there are different cooling methods.
Yeah.
Can you elaborate on those a bit?
Absolutely. Air cooling. At first you think, oh, that's the simplest approach.
Right.
But imagine if you have a red hot frying pan and you're just trying to cool it down by blowing on it.
Yeah, that's not going to work very well.
It's just not efficient.
Right.
Fluid cooling is kind of like the industry standard, and for good reason.
Okay.
So they circulate these specially formulated fluids through those channels we talked about.
Right.
And that allows the manufacturers to achieve, much faster and much more precise temperature control.
So what are these special fluids?
Yeah.
Is it just water?
No, not just water. Because, water can cause corrosion in the channels.
I hear.
So it's usually a mixture of water and ethylene glycol,
Okay.
which most people know as antifreeze.
Antifreeze.
And that prevents rust. And it makes the cooling system last a lot longer.
So it's not just about controlling the temperature of the part.
Right.
It's also about maintaining the equipment itself.
Exactly.
Clever. And also remember the source mentioning something about texture, properties, and quality.
Yes.
How does cooling impact those attributes of the final product?
Well, okay, so think about a phone case, right?
Yeah.
It's supposed to be smooth, right?
Yeah.
Well, if the cooling process isn't done just right, you could get an uneven surface.
Right.
Or even worse, it can create weak points that make it more likely to crack.
Oh, right.
And when you think about more critical applications like car parts,
Yeah.
the stakes are even higher.
For sure.
I mean, a poorly cooled part could fail
Oh, wow.
under stress, and that could have really bad consequences.
Yeah, no kidding.
So you can see that cooling plays a really important role in making sure that the part is strong and the quality is good.
Yeah, absolutely.
But it also affects efficiency.
Okay. Yeah, I was curious about that
Yeah.
because Arthrosis mentioned that faster cooling leads to like higher production rates.
Right.
And ultimately that saves money.
Exactly.
So can you expand on that a little bit?
Yeah. So as you know, in manufacturing, time is money.
Right.
So even if you just save a few seconds on each cooling cycle,
Yeah.
that can really make a difference in the bottom line.
Yeah.
So let's say you have a factory that produces thousands of parts every day.
Yeah.
Even a 5-second reduction in cooling time
Right.
could add up to hours saved
Wow.
every day, so you get more products made at
Yeah.
lower production costs.
So is there ever a trade-off though?
No.
Like could pushing for faster and faster cooling
Yeah,
potentially, I don't know, compromise the quality in some way?
that's a great question. And, it really highlights why the design of the cooling system is so important.
Okay.
So the goal is to find that sweet spot where it's cooling fast enough to be efficient,
Right.
but not so fast that it creates defects.
Right. Right.
And that's where things like conformal cooling come into play.
Conformal cooling, what's that?
Oh, that's just a newer technique where the cooling channels are actually designed to follow the contours of the part.
Oh, okay.
So it's more targeted,
Yeah.
do a more even cooling.
So
And that means you can have faster cycle times
Right.
without sacrificing quality.
Okay.
It's really fascinating.
It's a really intricate dance between like speed and precision and material science.
Yeah, it is.
It really is the unsung hero
Yeah,
of die casting.
it really is.
It makes you think about how much engineering and innovation goes into
Ah.
like all the everyday objects we take for granted.
Yeah, it really does.
Yeah.
Makes you wonder what other hidden processes are shaping our world in ways we don't even realize.
For example,
There's always something more to learn.
Yeah.
Even the stuff we think is boring.
Yeah, totally.
Pretty cool.
Awesome. Well, that's our deep dive for today.
Yeah.
Thanks for listening.
See ya.